These are the Maclaurin series that I'm going to want you to memorize. So we've actually derived these when we were playing working. I don't know if yes, we did e to the x2. So we derived all three of these, but these are the ones I'm going to want you to memorize so that we can use some substitutions and quickly get a Maclaurin series. So remember, these are Maclaurin series. Remember, that's when a equals 0. So if you're asked for a Taylor series, you cannot use these. So here we go. So if you started thinking about this, the derivatives would get not very fun because you would have chain rule and then product rule. So that's the reason that we want to use, and I'll just use Mac for short, we'll want to use a Maclaurin series, that's how you'll know to do this, to find a Maclaurin series for this. So I can see that cosine of x is this. So cosine of 2x squared will be substituting in a 2x squared in for the x. So cosine of 2x squared, sum from 0 to infinity, carry along the -1 to the n, carry along the 2n factorial, and I'm replacing x with 2x squared, and that's all to the 2n power. Okay, because of where we're going, I want you to simplify this. I want you to, I'm not a big simplifying fan. It's not a big deal, but there's a reason. So I want you to take this exponent and separate it and use it on both of these terms. So 2n distributes to this 1 and 2n distributes to this 2. So I'd have, not x, let's start with the 2, right? I'd have 2 to the 2n power, and then x squared to the 2n power. So let me just go really slow so you see what I'm doing, right? So I'm distributing this 2n to both of those terms, and let's put the denominator still back in, and then let's just fix this up a little bit. Those two multiply. So -1 to the n, 2 to the 2n. This will be x to the 4n over 2n factorial. 2n all in the parentheses factorial. So this is the Maclaurin series for cosine of 2x squared. All right, let's do the same thing to find the Maclaurin series for e to the 3x squared. So I see what e to the x looks like. So e to the 3x squared, sum will start at 0 and go to infinity. So I'll have 3x squared to the nth power all over n factorial. And again, because of where we're going, I want you to fix this. So take this exponent and distribute it to both of these terms. So I'll have 3 to the n power, x to the 2n, remember you're multiplying these exponents, right? All over n factorial. And that's it. Okay. So cosine is the odds, cosine has the evens, right? Cosine has the evens, and sine has the odds. Yeah? Okay, so just get to memorize that. So here we are. So, this has a multiplying by an x. Okay, so sine -1 to the n, 2n plus 1 factorial. All right, so I'm going to be substituting x cubed in for this. So this is going to be a little more challenging with the exponent. So I'm going to have x cubed all to the 2n plus 1 power. So, I wrote this out wrong. So let me fix that. So this is sine of x cubed. I will incorporate that x in a moment. For right now, I'm just doing sine of x cubed. N equals 0 to infinity. So let me just fix this up a bit. So I'm going to multiply this times this. So that means this gets to 3 times 2n plus 1. There's distributing that goes on, correct? So I get x to the 6n plus 3, right? Multiply 6n plus 3 all over this 2n plus 1 factorial. And that's the sum, or that's the Maclaurin series for sine of x cubed. Now I want to incorporate this x. So x times sine of x cubed means I'm going to multiply this by x. So I'm just going to go slow so you see what I'm doing. So I'm multiplying by x. And then what do you do when you have terms multiplied together? What do you do with their exponents? You add their exponents. So 6n plus 3 plus 1 gives you 6n plus 4. So negative 1 to the n, x to the 6n plus 4 over 2n plus 1 factorial.